Okay, so let's get ourselves started here. The first presentation is going to be from Amalia Calderón-Argelich. And the title of this presentation, I believe, if I have this order right, Predicting Climate Gentrification. So you can come on up, and thank you. Here's the pointer for you. Thank you. Processes that lead to extraction. These same discussions about the processes that lead to air pollution. One thing I was thinking about in your some countries like Pakistan far enough into the subtropics and mid-latitudes that have very different mechanisms for the heat waves. I think can lead to some of these positive correlations with some of the more tropical where it looked like similar temperatures maybe in the cold season and the warm season. If you look at out in the look at wet bulb temperature, I see more separation, the red moving more.
Super interesting presentation. Oh, thank you. I would really love to hear more, especially about like the toolkit that you developed and like how applicable it is to like outside of specific contexts you've looked at.
Yes.
Yeah. I don't know if you're in a rush to go somewhere.
No, I'm not.
I think you were speaking to someone else working in Pakistan yesterday when I was like the organization I work for is supporting humanitarian organizations, and really a lot of what we do is refer organizations to tools and expertise that can help them build a climate response into their work. And extreme heat is really an important piece of the organizations So I'm curious what your toolkit is and how relevant it might be in other contexts.
So the more analysis that we so New York City does have a extreme heat. I mean, it's not like physically like very.
True, so you're lumping together some different, but there's a lot of rain.
Yes, I actually thought I was running this morning. You're running.
Right.
So I have no.
Pakistan,
What I'm trying to do is like pull them out of parks and public places, even near like bus stops and all of these are like public spaces. So
I get it.
like from those topics, and I said like they need to be spread out. Tree planting drive in New York City some 7-8 years ago. Because they did complete the number.
here you can see similar Team X in the seasons, but very different air quality.
Yeah, and because this
Colder season, even on it's dry season. It's similar Team X.
I just the analysis is very much.
I'm sort of making a couple points. Yeah, there's a
Like some of these models are like super fascinating, but I'm like the organizations don't necessarily want to run them. But I think your approach seems to be also very much like I like the idea that there was like citizen engagement in it. So,
I mean, I do citizen engagement. I like citizen engagement. So I would like. I mean, the story map that I show is going to be published on the website. Where investors will like have work.
different mechanisms in different places here.
So when they say that okay, air pollution,
Season, especially during the El Nino years.
kind of, but the toolkit would be like the toolkit would be more. I would love to have the toolkit
Really high pressure,
Yeah.
almost like what we get
that
in New York, where you get
looking at
it's very sunny, very dry.
Right. Okay, but the methodology could be super
Something to add to that is more use and space specific. So she had recommendations for parking lots. So what you can do for parking lots? What is the proximity of parking lots to a public space, or is a parking lot on a street intersection? So then you have an opportunity to extend
Just a lot of things to
from
look
parking lot to the site. And so there were like so many iterations that were discussed and went through, but it was like more space and use specific.
Very cool work. How can I follow up with you to get to hear more about the methodology and maybe connect
And if it's
to
helpful, again, so I sort of organized that project that Steffen presented as part of the
collating of
workshop that we
these
did.
approaches?
So we almost did a compound, because that was the year we had incredible heat last year. But then heat was really bad.
No, the story map is going to be published. The iteration that I showed you is the one that I created like a first
That could even be a
then I
follow-up.
worked with them to create a one that I
Yeah.
really wanted
Sorry to interrupt. I just wanted to- yeah.
stuff, but
Okay.
Looking at interconnectivity, it's a site where people have
Find my name that way. It's like,
That's easier.
so much easier.
that might be some interesting.
Yeah, so it's helpful to introduce you to some of the broader team as well.
yes,
It's a lot for you to think about on this one.
yes, and yeah, I'll ping you and then we can follow up. I'd love to talk
Want
to
to
you
see some
and
wet
like
bulbs?
see if I can.
But also,
There are ways to like develop this further or
processes.
I love that.
I think there certainly can be, and there's a lot of interest right now in trying
Countries,
to
it differs a lot, right,
understand
by your sort of wet regimes, like.
the impact of heat in humanitarian contexts, and I think there is a gap in starting that work and like knowing how to do it. I mean, these organizations are seeing and experiencing, and the communities they work with, like, they're trying to like develop programs, but it's having it be informed by data analysis in some way, I think could be really helpful.
Yeah. My strategy is also like adaptation in place, so I really didn't look at like if people would move, because it was too hot, so I was like more focused on
Alright, I
keeping
gotta
them
run.
in
Good to
place.
see you, yeah. You gonna be in New York for a while?
I'm heading to DC this evening.
Yeah.
Bye.
So many different
Yeah, thanks for telling me about that. So would it be a secret that
Yeah, I really like yours too. We studied Barcelona. Our professor is from Spain.
resiliency study, and I'm using the same exposure sensitivity and adaptive capacity, but I'm not using that formula. It's like I'm putting them on a graph. Really? Exposure versus adaptive capacity, and that divides into.
Thank you so much. Thank you everyone for being here and for staying until the very last day of the conference and going to the session. For me, it's very nice to me to be here, also coming from Barcelona, because I think that usually there, more in the European context, I'm like the only one trying to bring the climate gentrification concept into the conversation, and I feel like here everybody is like quite well situated about what this is about and the problematics and so on. So I think it can be like more directly into what we've been doing. And also looking forward to hear not only your questions but also suggestions, because I think this is like a work in progress. So this is part of analysis that can be also a starting point for further analysis and inquiry. So for your suggestions too. So I'm part of the Barcelona Urban Lab for Urban Environmental Justice and Sustainability, which is directed by Isabella Angelowski. And we're going, part of our question, the driving force, is to what extent does urban greening contribute to climate and health justice, rather than reproduce existing inequalities as part of urban redevelopment. And in this project, we're focused on the Barcelona metropolitan areas, so a very compact and dense city with new green spaces, but also with many different socio-economic inequalities related with these land redevelopments. So as cities are increasingly adopting green infrastructure for removing functionality and the low-cost climate solutions are the whole momentum for nature-based solutions and improving resiliency, the conversation has been very much in parallel, so there's not been a real conversation between like housing and climate and affordability and resilience. Increased access to nature tends to be presented as a universal health, therefore, and social benefit for all residents through a simple trickle-down effect of exposure benefits that we know here it's not really reflecting the complexity of reality, no? the concept of climate gentrification, we work with understanding it as an exclusive climate protection, maladaptation, and unequal green climate security. And our core hypothesis in this project is that working class and racialized minorities are the least able to adapt to climate change due to higher displacement vulnerability when living in gentrified areas with climate-protected neighborhoods and when having lower access to social adaptive infrastructure and secure affordable homes. So there's this strong correlation between land cleanup, investment in open space creation or rehabilitation, and changes in demographic trends and neighborhood property values. So how they are intertwined with environmental transformations and inequality and gentrification. Our recent inquiries and questions in this project of this research we're doing is how do different climate drivers and climate responses shape the ongoing gentrification, present gentrification and also future gentrification, trying to take this kind of proactive approach. What methods allow researchers to tease out lived experience and the vulnerability to this gentrification, and what areas in metropolitan areas are more exposed than others. So this project is called Climate Justice Ready, it's part of the lab, and it's about what I was saying before, of predicting and preventing this green climate gentrification in adapting cities. So we made a big exercise of co-mapping these future climate injustices through trying to move beyond the analysis of, okay, this area has been gentrified or not, and taking this proactive approach of which areas are potentially more gentrifiable than others, and through a participatory process. So also trying to move away from academic expert-driven vulnerability analysis, and also through refining the different climate drivers of gentrification, which can take many forms. These drivers and risks, we understand them as exposure ones that are climate impacts and environmental conditions, and also the investment in resilient infrastructure. And then what we understand as sensitivity are the mapping the socially vulnerable residents and the areas with neighborhood revitalization. And finally, we're also trying to take account of the adaptive capacity of cities and different areas of the city through social housing and adaptation of social infrastructure. How we did this, we did a very quantitative index, doing a mapping of indicators using this more classic vulnerability equation that displays, and it's widely used in climate adaptation and climate change and environmental studies that understand vulnerability as the summatory of exposure, sensitivity, minus the adaptive capacity. And therefore, we collected different indicators, which one for each category. So in the exposure category, we first mapped, we created this sub-index called exposure with indicator of air pollution, hours of discomfort in summer at home, so like this climate exposure, and also the construction year of the building, the proximity to green and blue infrastructure. I created this index to see also like which are the areas that are more exposed. This is the Barcelona city, and the whole is the metropolitan area. So also we were trying to move beyond only focusing on the city, but the whole area, because the limits or the frontiers here are really not that clear in the lived experience. So it's very fluid, and a lot of people live in an area, work in the other, and so on. This is the collection of the whole indicator, all indicators with the units and so on, if you're like further interested. Then we collected the sensitivity indicators, where we accounted for recent gentrification, because we understand that areas that has already been gentrifying and potentially keep gentrifying, and also related with social and health vulnerability. Also, I didn't say that our way to understand climate adaptation and climate gentrification is very much focusing on heat. Why? Because heat is one of the most present threats related with climate change in Barcelona, and there are many indicators and municipal efforts being done already towards heat adaptation. So all indicators were very much focusing on either the adaptation to heat or the vulnerability to heat, and this is also why we use some of these particular social sensitivity ones, like people over 75 living alone, or energy poverty, which is very much related with the capacity to keep houses in a good condition. So these were the sensitivity indicators. And then the adaptive capacity, which is always a category that it's sometimes more difficult to grasp in a geolocated way. So we included the climate shelters, which is a municipal program similar to cooling center, what you call cooling center here. So public infrastructure like community centers, public libraries, or museums where you can stay and be in a comfortable temperature. So this kind of infrastructure where the ones that we understood as adaptive capacity, and also like the public housing, which in Barcelona and Spain, the ratio is very, very low, 2% of the. And so with all this collection of indicators, we had the first attempt of a vulnerability index for climate gentrification, which looks like this. When this looks like this, when you put together all the indicators, giving them the same weight, so like that's the same ponderation. And what was interesting to see is that actually the Barcelona area, the central area of Barcelona, is the one that is less vulnerable. So the results, it was interesting to see that puts a lot of emphasis on the peripheral areas, which tends to be areas that the conversation on gentrification is not really focused, because most of the traditional gentrified areas are like very commercial areas, tourist attractive, and so on. But now this kind of proactive or like potential gentrification approach, it was interesting. We had a conversation with the municipal planners and people from the Metropolitan Area Agency that they were like, wow, this is unexpected and can help to bring it to the table on the public agenda, gentrification, and I think that other municipalities, the peripheral municipalities, also have to take into account. So this index was a composite index, but we gave the same importance to all indicators. But then we had the question of, well, maybe some sensitivity indicators are more important than others, or like what is our criteria, whether is it representative or fair to give exactly the same importance to all of them. And this is where we included the participatory process part by asking how can a participatory and collaborative mapping contribute to a more nuanced and experienced understanding of vulnerability to climate gentrification. And then we organized some workshops with some administration practitioners from the different municipalities that form part of the metropolitan area, and with some activists and grassroots communities to ask them also, like, what do you think is more important? What is your lived experience? What resonates more with you? And so we made some like interactive online workshops when we discussed every indicator, and this also was like it was a very interesting conversation, because at the end having the quantitative ponderation was not our only goal, or was not the most important thing, but to understand also whether they understand what is climate gentrification, how they understand what things resonate more with them. And so we did those two workshops in separate, and we have like the different ponderations that we could compare between the grassroots communities and the administration. And for instance, we found that the administration practitioners give much more importance to the adaptive capacity, whether activists put more emphasis on the exposure indicators. For instance, one of the practitioners' quotes said, for me, the main cause of gentrification isn't so much that you have improved that area or not, also because I feel responsible for improving or not that area, is the fact that there are no housing policies allowing people to stay there, not the fact that the area is better, because it's something everyone should be able to, right? Other differences when we went to the concrete individual indicators were administration gave more importance to heat discomfort at home, the year of construction, things related with the buildings or the income, while activists gave much more importance on social vulnerability like rent or being born in global south countries or the proximity to new parks. And so with the different ponderations we got, we could build actually 3 different indexes with 3 different ponderations as a way of as 3 ways to represent reality according to different understandings of and priorities. So just to compare a little bit those 3, we see that equal weights, as I said, the highest vulnerability is outside the Barcelona city, in the periphery, because all these areas are much more greener. Here there's a natural park, forested area. Here there's a lot of agricultural green areas. So this is a strong impact from exposure, whether in Barcelona there's low to medium vulnerability. And then when you compare with the index according to administration practitioners, you see that higher heights are assigned to infrastructure and housing conditions, which may downplay social vulnerability factors linked to the gentrification processes. While the activists and grassroots communities gave much more importance with the high green space combined with higher social vulnerability that we can see in certain areas of the Barcelona city center, and also more related with previous trends of gentrification. So what do these differences tell us so far is that the practitioners prioritize these exposure indicators to put the accent on community and also put the accents on community adaptive capacity as a tool for reducing climate gentrification, so emphasizing the exposure as core drivers of climate gentrification and reflecting their institutional mandates to implement infrastructure solutions to improve adaptation for all, while the grassroots designate exposure and sensitivity aligning with experiences of socioeconomic vulnerability and displacement risks and housing justice struggles. Some of the study takeaways that we take from this is that institutional mandates and daily experiences of climate vulnerability shape this weight association for the vulnerability to climate gentrification. We see this high vulnerability in the peripheral areas of Barcelona and the importance of metropolitan-wide dynamics of climate impacts and gentrification patterns. And some policy takeaways we take from this are the importance of bringing together these dual expressors of increasing heat and gentrification through climate and housing, which is a conversation that is not really there on the administration side and neither that much from the activist side. And this creates opportunities for integrated strategies and policies that address both exposure to heat and sensitivity to climate heat gentrification, and also the need to further explore adaptive capacity measures that resonate indeed with communities. Some of the best practices and challenges that we see from these are the importance to make these climate shelters programs truly accessible. This is like the program, the distribution of the different climate shelters in the metropolitan area. The importance of housing retrofits in targeted socially and heat vulnerable neighborhoods, although we identify different administrative burden and the potential for speculation. And other challenges is the sectorial silos between climate action, housing, greening, and finally the need for targeted interventions in peripheral areas with these compounded effects of climate exposure and limited adaptation resources. If you would like to know more about this, also through this process we made a collection of videos with different communities in the Barcelona and also in the Boston area. And then I invite you to check out our website and see the videos and the different information we can have about it. And that's all. Thank you so much.
Thank you, Amalia. That's great. We're going to hold questions actually until the end. just because that went just a little bit over, but hopefully there'll be time for a question for you at the end. Okay, next up we have Aditi Galande talking about Beat the Heat, transforming pedestrian corridors for seniors in Mott Haven, the Bronx.
So good afternoon, everyone. So from one urban center to the other, I'm bringing everyone home. So back to New York City. And I'll be talking about, this is a capstone project that I developed over a period of 4 months. It's a semester-long project. And typically we have a client on this project. So my client for this project was South Bronx Unite. And I've been very, very fortunate and grateful to work with them on this project. A little bit about myself, so which kind of also shaped my project. So I'm an architect and So I'm an architect. I specialize in landscape architecture. I did my grad school at Pratt, under which this project was developed, and into system thinking and sustainability. I have about 6+ years experience in design and planning, and so my kind of recommendations stem to both policy and design recommendations for this project. Currently, I work with this firm called Plus Lab Architect. We're based in New York and LA, and I focus on comprehensive planning and regenerative design. So let's dive into it. Okay. This one? On the screen?
Yeah, now try again.
With
There you
this?
go.
Okay, this one? Okay, click, okay. So my agenda for today will be like, I'll talk about my challenge, about my process and the outcomes. So as we all know, and I think at the keynote also it was kind of discussed, that we're all in this place of like where it's getting hot and it's getting like humid as we like go along. This rising temperature is like affecting everyone. It's like affecting urban areas as well as peri-urban areas. And it's kind of like just not like the question of disrupting daily routines, but it also like restricts our outdoor activity. And so my focus for this study was like looking at outdoor heat exposure. And how is typically heat vulnerability mapped? So heat vulnerability, or rather heat is mapped in terms of heat vulnerability index, which consists of these 3 factors: exposure, sensitivity, and adaptive capacity. And then they have like these sub indicators inside them. And New York City did one such mapping. They created a heat vulnerability index map, and they used 4 of these indicators from the larger buckets that I showed earlier. So surface temperature, green cover, access to air conditioning, and low income. And what this map essentially starts showing is the disparities in heat vulnerability throughout the city. Like some neighborhoods in some boroughs are more like high heat vulnerability index than others. Like for example, the Bronx and the Brooklyn. It's also like Upper Manhattan kind of where we are located. So we are located near an heat vulnerability index area, but not exactly there. And what are the different factors that could be contributing? So obviously the built environment is a major contributor to this HVI index. So the land use patterns and like high building density, heavy traffic. And what you're seeing even in cities right now is all of this is coupled up kind of with low income or like income levels and minority status. And that sort of deters your capacity to cope with this heat, these social factors. And but we're still talking about like heat on a very large scale. And so I started looking at this concept called what is the experience of heat, and that can be captured through this this factor called thermal comfort. And thermal comfort consists of some factors which are mean radiant temperature, like it's kind of like what you feel, so the air temperature, the humidity, the wind that's coming. And then there are also personal factors like what's the activity you're doing, what's your clothing, what's your health status, or what's your age. And combining all these factors, I kind of defined my vulnerable population, which is seniors. And this is because seniors start experiencing like fatigue from heat for temperatures as low as 80 degrees Fahrenheit. And sometimes they can have like low understanding that how this temperature affects them, and they'll step out. And this long-term exposure can actually exacerbate the existing health conditions that they have. So, and if outdoor activity is restricted, as per CDC, it says that that can actually impact just not their physical health, but mental health as well. So, I mean, you want them to step out, but it has to be a safe environment. Additionally, like the map showed earlier, there are neighborhoods where seniors don't have access to air conditioning, and so they will step out to go to the nearest cooling center or the park. And while they're accessing these amenities, they will be exposed to outdoor heat. So it's kind of it's like counteracts with what you're trying to do. So that's what I started looking at, like mobility corridors as a main thing. And there is work going on in New York City related to extreme heat. There is also work going on in terms of like there are stormwater related policies that have co-benefits for extreme heat. But all of this is still going on at a very large scale. There's the agent specific approach, or the experience capturing approach is kind of still missing from all of the studies, what I started realizing. So I focused my my project on a neighborhood system, on the pedestrian and basically the mobility of the street network. So the neighborhood that I selected, which also my client kind of works very, very actively in, is the Moat Haven neighborhood, which is located in the southern part of Bronx. And it is actually a really, really beautiful neighborhood with a lot of like art and culture and embedded in it. But there is also the same thing, there is an aging population in this neighborhood. Like our keynote speaker pointed that there is an increase in aging population. We're an aging society right now. And there is 11% seniors in this neighborhood currently. And just a glimpse into an overview of a systems diagram that I developed for this neighborhood. So this neighborhood currently has the highest level of ozone, just about 11% of tree cover. It has only one green space, and it is always in the news for being hardest hit by heat waves, unfortunately. There's also very low passive open space in this neighborhood, and all these factors are kind of like what I defined could be contributing to thermal discomfort. And then going on to the other factors, which are the socioeconomic factors, is that it has high poverty rate. It also has high cases of asthma, hypertension, and all of this, like if you restrict outdoor activities, then that creates like high vulnerability as well. So a little bit about my client, and they are an amazing organization working for a long time on air quality, like air pollution, which is a major issue in this neighborhood. But recently with Columbia University, they did a study of heat mapping with Kappa strategies. And this is the study which kind of inspired or motivated me to dig deep, because they started talking about these hotspots, which are attributed to neighborhood or physical conditions, social conditions contributing to these heat vulnerability. And so my process involved like identifying these neighborhood trails, or like sort of because it was a 4-month, it was a short kind of a project, so I couldn't conduct a community engagement per se. But then I started using these pseudo indicators to identify where seniors might be going in the neighborhood. So those indicators were like, where could they go for functional activities, for recreational needs, or even like looking at transit nodes to see that these are the places where seniors would be gathering to sort of access those things. And so I identified these key pedestrian corridors based on this. And these are just a few maps of what I have produced. So this is the medical needs, so basically location for pharmacy, shops, and medical facilities. And these are some cooling amenities. So like you can see that most of them are like focused on these streets, but like important thing to notice in that is that the green thing is the only big open space there in the neighborhood, and all the other brown are the playgrounds, but they're all asphalt finished playgrounds, which are contributing to heat, like instead of like actually giving any respite from heat. So based on that, and on a few more maps that I created, I developed this key pedestrian corridors, and I overlap these key pedestrian corridors with the heat vulnerability indicators, the ones that I showed you earlier, the exposure, sensitivity, adaptive capacity indicators. And so I use surface temperature, heat indices, looking at census tract level, understanding where seniors are located, and also which census tracts have seniors which are living alone. So that kind of helped me derive these hotspots. And when I overlapped that with surface temperature, I started identifying these, like physical spaces where or at least some sort of junctions or places where there is high heat vulnerability index as per the map. I also use this exposure category, which is the evening heat index, and I started identifying spaces where it's showing like the maximum temperature that was recorded. And this is the census tract level where I identified like census tract 39 has maximum seniors living alone. And then I also kept talking to my client about this. So there is a lot of public housing in this neighborhood, and the census tract 39 actually has public housing which is focused on seniors. And so that's why I guess it also shows like a very large population of seniors in that census tract particularly. And after I did that as a desktop study, I wanted to ground truth all of these findings. So I did a site visit with site observations, walking on all of these key pedestrian corridors that I'd identified to see what's exactly happening, what are the factors that are contributing to it. And I also talked to some community experts. I took these findings to them. I talked to them. I asked them like, what have they observed? What are their like takes on this? And from this, like this is just another like few photos, but there is more comprehensive in my report. But I started like noticing these small things, like a lot of paved area on passive spaces like street triangles and medians, which are like important open spaces. They have benches, you know, for people to sit and relax, but it's very highly paved. Also, there are empty tree pits, which are like lost opportunities. There are parking lots along the sidewalks, which are asphalt covered. So all these are contributing to the high heat, the hotspots that have been identified. And so my outcomes, so basically like 5 outcomes that I came up with is basically this neighborhood lacks shade, any type of shade, like where people are gathering, like waiting for their bus or outside the subway stop. There is no engineered shade if natural shade is not possible because of infrastructure. And then there is also insufficient canopy cover. There is loss of vegetation potential due to empty tree pits. There is land use that is contributing to heat, like highly paved areas and asphalt covered parking lots. From my expert interviews with community leaders, I found out that there is a geological limitation in this neighborhood to actually go for traditional green infrastructure solutions because it has a high bedrock and low soil. So trees don't survive, like trees will just die, you know. And there's also the overlap of air pollution to heat. So the ground level ozone and on a hot day sort of is a very bad combination for respiratory disorders, and it kind of like makes that condition worse. And so my first recommendation is based on like a policy level recommendation where I'm saying that the city or like any kind of these studies should have an agent specific sort of analysis and agent specific consideration when doing these kind of analysis. And when I was working on this project, like there was a study that the New York City Department of Transportation was conducting called the Cool Corridors Program, which was a study that they were doing to identify best practices for extreme heat on corridors. And I said it could be paired up with this study, like, you know, where they could do the analysis or look at best practices around the world where such kind of analysis has been done. And then my second proposal is like a design proposal. So this is a proposal where I'm recommending to create like this cool trail network and along the key pedestrian corridors. So it's essentially prioritizing the streets that I've identified as key pedestrian corridors for adaptation and mitigation strategies for heat. And I went on and I created like a toolkit for these strategies. And these would have like multiple stakeholders. It would have to be more of like a community-based sort of input also would be required for this. And so the toolkit that I created was something like this. Like it was like mitigation strategies around the four strategies is like increasing shade, vegetation cover, trees, and like, you know, increasing access to water. Yeah, another point which I forgot to say is that in New York City, like you can only have like water amenities related to parks. If there's a park, then there's a water amenity. And if your neighborhood doesn't have many parks, then you don't have many water fountains. So that's like a challenge, like when you're walking around the neighborhood, if you're thirsty. Anyways, sorry. So going on to like the typologies. So then I focus on the typologies that I identified as like problematic typologies, you know, like sidewalks and streets and parkings and even bus stops. Like I said, the bus stops don't have shades. And then there are some adaptation strategies for awareness and outreach, like warning systems near bus stops, near like transit hubs basically. And this is a very conceptual first level master plan that I created, identifying where these strategies could fit at like the first go, like depending upon what I observed, what I talked to my client about. just one example of a mitigation strategy is like, this is what the typical sidewalk in the neighborhood looks like. This is what it could look like with a tree, you know, and the type of foliage. I also defined like a type of foliage that could be used. If in case, like I said, if there's a geological limitation to go for this, then something like this could work as well. And the third strategy, which I talked about, which I sort of recommended, was a community engagement strategy, is introducing conversations about heat in all of like community engagements. So my client currently is doing a community engagement for a Moat Haven Port Morris waterfront plan, and they could introduce like focus group engagements on extreme heat focused on seniors, so those kind of tabling sessions. And they have found success in the past with this ArcGIS story map. So I created a story map about my project for them, which they could share with their community and with the people. And yeah, I'm almost at the end. So I just keep track of what's sort of ongoing in the work of heat. Of course, I've learned a lot even in this conference, but I've been attending like stuff around, and I can see NPCC this time I'm hearing is doing their next report focused on like heat, humidity, air quality. They are looking at doing population-based assessments, which is yay, and identify like vulnerable groups in that, and also neighborhood factors. So kind of building off of what I'm doing. So it makes me happy that, you know, I'm doing this, and then somebody else is also like looking at it in the same way. And that's all.
Thank you. Anybody? Okay, I'll riff real quickly on when you're talking about like the thermal index and looking at the sort of exposure side. How do you get the sort of specificity block by block? Is that satellite images of radiant? What's the sort of connection between the thermal index and sort of how you're getting these sort of micro scale measurements within a neighborhood of exposure?
Thank you for the question. So it's kind of hard to do that. The map that I have right now, which is the thermal index map, that was created by as a citizen science project by people in the neighborhood going around with actually sensors. So, but they were still on like bicycles and cars. So, and I'm actually capturing the pedestrian experience. So maybe like what my recommendations are, like, you know, like if they say that this is what it is, then the recommendations need to go like more conservative, because this is a person walking versus, yeah.
Sorry, real quick.
Oh, it's just more of a comment. Really great work. Two things. On that note, there are some interesting methodologies that can help you overlay and make sense of, say, like satellite imagery and to disaggregate the census blocks. So there's some interesting methodologies there, so you're not like bound by a census block necessarily. And you can use like Landsat data and things like that to overlay some of those methodologies. The other thing, and I noticed this in both, and maybe we can pick up on this in the other Q&A, but we're talking about people potentially leaving because it's too hot, for example. There's also, you know, this is like really related to real estate development, density, etc. So there's another side of this question, which maybe you have perspective about later on, about the relationship between increasing density, real estate development, and the impact that that has on extreme heat. It's just more building. Yes, good call. Yeah. Thank you.
Thank you. Okay, great. Okay, great. And I'll do a quick introduction. This is Steffen Lohrey speaking about exploring responses to ever-increasing heat.
Steffen, are you able to share your screen?
I've already requested screen sharing from you.
Yeah, you're a co-host, so it should be all right.
Oh, someone else is sharing.
Okay, try again.
Yes. Okay, let's see whether the presentation will come up. Are you seeing the controller or the actual presentation?
We see exploring responses to every.
Okay, perfect. Thank you. So thank you very much for, I'm a bit intimidated because I see quite a lot of people online and then a full room. So thank you for giving me the opportunity to speak. And my apologies first that I can't be there. And second, this is really ongoing research. And so this talk doesn't present results yet, but a lot of concepts around it. And I think actually I would like to have some, some discussion, and please feel free to catch up with me later and help me shape that research and get involved if you want to. I'm usually based in Berlin, Germany, and I currently have the opportunity to spend the summer at the International Institute for Applied Systems Analysis in Luxembourg. This is actually a UN entity which does a lot of the climate science research, and people who've worked with the SSP scenarios of climate sciences are probably familiar with this because they've been largely engineered here. Let me talk about how I think about the extreme heat problem. So I've looked at heat over the past years, and I'm starting to try and understand how does it actually how does heat affect people and their migration patterns. And when you look at heat, in particular in cities, I feel there's a technology adaptation component where you can look at air conditioning, and particularly maybe also some other building technology. There's a very strong urban form and structure argument, but this is looking at, how is your city built? So nothing that's going to change soon. And then there's nature-based solutions that are in the room. What's not in the room is the migration. This will come. There are constraints like implementation time, there's competing effects, and also how to use the urban space from an urban economics perspective. When I do my research, it's very interesting because I'm also on the global front. So the first two presentations were highly local, and I found this very, very interesting at the very right-hand side of this. And I come much more of a global understanding now, trying to understand how do, sub-city level actors make decisions to move or to adapt or react to heat. And when I speak about resolution, I really mean there's a temporal component. So if you look at heat, what are we actually looking at? Are we looking at 1 days? Are we looking at heat that's just temporary, like all the time too hot? Is it just a single heat wave that's maybe very, very dangerous, but otherwise it's largely fine? What's the spatial resolution? I've talked about this. And then if you go more into the heat detail, you can look at what do you actually talk about when you say heat? Is it temperature? Is it wet bulb temperature? There's a lot of discussions on this. How do you measure this? Very briefly, I've done some exposure, or there's actually been a lot of research done on exposure, because I feel this is the easier fish to catch, where you look at population numbers. So what you see here is the aggregate urban population in millions according to 3 socioeconomic scenarios. So to the left, you see the sustainable scenario. SSP3 is a much more fossil fuel driven scenario, and SSP5 is sort of a global sustainability scenario. Where you see that population largely peaks around mid of the century. And then what does that mean to exposure? So this is for the same SSPs, days of deadly heat in these cities, in these world regions. What we did here is we used a very, very rough binary definition of a deadly day, which is roughly around a wet bulb temperature of 35 degrees. If you do this, you can, there's lots of studies doing this. In this study, we look at heat, like in some areas of the world, there is massively increasing heat, which would be on the x-axis, and in other parts of the world, there is massively increasing population or stagnating population, which is on the y-axis. So there's a lot of this. The other much harder thing to do is the adaptation and the societal response. There's a few things here to say. There's air conditioning, there may be behavioral adaptation, there may be infrastructure responses, and there may be migration, which is what I'm trying to study in this project. First, infrastructure responses. I would briefly like to highlight a research we've been doing, or just submitted, which is on the effect of urban greening. And essentially, going very quickly through this, what we did is we looked at street green space. How does existing street green change temperatures? We control for location-specific controls like the urban form, water, your population density, and then create projections of future urban green to try and answer the question, is urban green actually able to mitigate some of the additional heat from climate change? So if with climate change you have more heat, is urban green as a nature-based solution able to take that additional heat away so that in an urban area, your climate change burden, can get managed. What do you mean with urban green? We kind of measure this from Google Street View using a machine learning algorithm, where this is an example from Singapore, where you assess this number with GVI 54 here, which is the metric for how much urban green the observer sees. This is an example from Yaoundé in Cameroon, where there is much less green. You have this green patch here to the right. And then we see that we have very strong differences between climate zones and urban forms. So we can kind of structure our cities for climate zones and urban forms. We create scenarios for this. So within this set of 181 cities, we look at the sort of achievable within climate zone and urban form. We create scenarios of a pessimistic one where we kind of go to the lower boundary of what we observed, a moderate ambition where we go to a 75th percentile boundary, and a high ambition scenario where we go to an upper boundary of what we observed in this data set. We obtain trains cooling efficiency. I'm not going to go into detail with this. Essentially, it's a statistical analysis with fixed effects regression analysis where we look at these various factors. And most importantly, what we get out here is this very confusing figure for a few example cities, where you can see the left four bar charts in each panel are the additional wet bulb globe temperature under SSP 5 8.5 scenario in 2100. And the three right bars are the mitigation potential of trees. So on the left-hand side, you see how much warmer does it get from climate change. And on the right-hand side, in these three bars, you see how much can trees take away. And the results, even in their sign, may change from climate zone, from city, but largely urban trees are not enough. So the heat, I've put this here in bold, heat reduction potential of SGS is street green space, generally is not large enough to fully abate additional heat from climate change. So infrastructure responses may not be a solution at all. It can help. And I really like this, this talk on New York City and the Barcelona one where you highlight the effects of green. So you can see green that can have an effect, but it's not big enough at large to look at climate change. So there may be behavioral adaptation, there may be air conditioning. And this is something I'm much more looking into right now, where we're looking at climate data and trying to see where do people pick air conditioning. And so just some words on this. Air conditioning may be a viable adaptation strategy. So you have places in the world that may be considered uninhabitable, but they have very heavy use of air conditioning. And less sort of adapted traditional behaviors. But we also know that air conditioning has a strong inequality, both locally and globally. And here, what you see in this figure is a paper from a recent publication from Giacomo Falchetta, who's one of my co-authors or co-researchers on this project, where they projected future air conditioning use, depending on climate zone or depending on where you are in the world. I've worked in another project with the Red Cross in Hanoi, where we looked at adaptation strategies of low-income street workers. So this was based on a survey and trying to understand how people cope on very hot days. And there were two main takeaways. The first thing is you go to public cool rooms, they use fans, so you just try to stay cool as you can on very, very hot days in Vietnam. But overall, there was a very low awareness of health risks of heat among these outdoor workers that were sampled. And so the problem is, and this has been highlighted in the first two talks, that you need to have this access to air conditioning. And so the question is, when do people start to move, or do people maybe not move because they're not able to? Very briefly, going back conceptually, how do we approach this? This is a very, very difficult thing to do. And we've actually just submitted a paper where I was a co-author on this, where we tried to estimate displacement from floods using flood depth And that's much easier to do because when you have no water, you don't have a reason to get displaced from flood. And then the question is, how deep does the water have to be so that you move away? And the takeaway is, given the rough and limited data availability we had for the floods in Pakistan in September 2022, the estimates we found using a relatively straightforward flood model were relatively good. And the question is, can you do something like this for heat? And I find this much more difficult than I thought it would be. And I think this is why also a lot of people have interest in this. There's a lot of papers and some discussion around a deadly threshold, where often wet bulb temperature of 35 degrees comes up. This is a paper by Radley Horton, or short comment, where it's shown the areas in the world that exceed or like that have strongly increasing wet bulb. This is wet bulb globe temperature, but essentially extreme heat. And you see highlighted these highly populated areas in Asia, but also parts of the Arabian Peninsula. And there's a very recent paper where the effects on mortality due to the urban heat island effect is highlighted, which is then strengthening the problem. And what I'm currently doing is asking this question: when does heat actually become a reason to move? So as with floods, you could say, okay, when the water is 2 meters high, this is probably when most people leave their house because it's not viable to be there, it's dangerous. With heat, it's much less clear. There's maybe air conditioning, which may be able to shield muddled with many other factors. So for air conditioning use, you need to, there's a strong effect by income. Income is a very, very important factor. And then you have many other reasons why people would migrate. Heat is not the only one. Yeah, so this is the research I'm currently looking at. Essentially asking the question, is there a critical temperature? Is there other environmental conditions? And then in thinking of these 3 pillars of technological adaptation versus maybe a reduced standard of living, which means like bad quality of life because it's very hot, versus migration. And I'm doing this IASA with Kai Konhuber and Giacomo Falchetta at IASA. And very happy for you to get in touch. And thanks for listening. Hello?
Sorry, Steffen, can you hear me?
I can hear you, yes.
Okay, great. I don't know if you could hear me before, probably not, maybe
No.
not. Okay, good. I apologize. We have time for one question from the room. Yes, please.
Hi, hi, Steffen. I'm Hebe from King's College London, and we're also researching heat and in Pakistan as well. And I'd love to connect with you after this. But what I was curious about with when you were discussing migration, like trying to work out when people were migrating from heat, I was curious about whether you were considering temporary and seasonal migration within that, or whether you were just thinking about permanent migration. One of the things that we're seeing in our research in Pakistan is that people are already moving to manage heat seasonally, going to cities nearby at times during the summer months. So I just wondered whether that was something that was part of your research as well.
Thank you. I hope I got all of the question. There was a bit of a lag, but I'm thinking about permanent migration actually, but it's a very, very good question because I think, as I said a little bit with these cooling centers, that there is an element of a temporary relief and in the hot season or during a heat wave, you may go somewhere else, but then you actually go back to this place at the cooler time of the year. So I think this is a very good input for me to think about, that people it's not binary. So yeah, no, I'm just looking at permanent migration. When do places become uninhabitable? And this is something that's not happening right now, but this is something that may happen in future climates and kind of soonish.
Great, thank you, Steffen. And yes, we'll follow up to connect these two Pakistan research streams. Okay, great. So for our final talk, last but not least, we're going to hear from Yujie Zhang talking about population exposure of rising heat stress and pollution risks.
Makes sense. Thank you.
Hello, my name is Yujie. I will be a postdoc at University of Pennsylvania, and this is an ongoing project co-authored with economist Minhaj Mahmood from Asian Development Bank. So the title is Population Exposure to Rising Heat Stress and Pollution Risks, Evidence from Selected Asian Countries. Okay, so let me first motivate this project. We are curious about who is more exposed to heat stress and air pollution risks in terms of like working status, age, gender, and some other demographic characteristics. And we want to study Asia because, like as shown by Michelle earlier, Asia, especially like South Asia and Southeast Asia, face high exposure to climatic and environmental hazards, and the climate change exacerbating risks to human development. And the existing papers already show that near-term cognitive performance, health, and educational performance are all cumulatively affected by extreme temperatures, and also pollution exposure can negatively affect those factors. And then we're also curious about, are certain population groups simultaneously exposed to the both shocks? The current papers usually, we can categorize the current literature into three groups. One group studies the air pollution risks only, the other group studies the heat stress only, and the third group of papers study the interactions between those two factors. And we argue it's important to first check the correlation, because the interaction between the high temperature and air pollution increases mortality rates and also affects human health. And also the directions of those interactions are still uncertain. For example, the higher temperature can increase the harmful air pollutant levels, such as ozone. And then meanwhile, when the air pollution is really bad, then the pollutants can actually reflect the the sunlight, and it can somehow decrease the temperature. So there is uncertain directions of the interaction. But I'm not a natural scientist, so I don't study how those should work. What I'm curious is, are people simultaneously exposed to both shocks? Okay, so let me talk about what data set we're using. The first data set for the heat stress is the Universal Thermal Climate Index. And it's derived from the ERA5 heat data set from the ECMWF atmospheric reanalysis. So it actually, the unit is still temperature, but it actually describes how human body experiences the conditions, including the air temperature, humidity, and radiation and some other factors. And it's hourly available and graded dataset with 0.25 resolution, and it's available from 1940 to the current year. And the second group of dataset we're using is for the air pollution risk. We use the global PM2.5 data provided by Washington University in St. Louis. And they actually integrate the satellite simulation and the monitor-based sources. And then they provide this PM2.5 measurements at the monthly level and also yearly level. And for a finer, level, we use the monthly level. And it's also graded for at the 0.01 resolution level. But the period that is available for is much shorter. It's only available from 1998. So that limits our project a lot. Okay, so I want to show you how we do the spatial merging. So, and I will talk about why we want to focus on this district level analysis. So we have those the air pollution and also heat data at the coordinates level, but then we actually only have the population data from census with the district information, also like the province or like state information. So we need to make some decisions about how to integrate those data sets. And we decided to go with this spatial merging by, for example, for every district for the hourly temperature data, UTCI, we average the UTCI across all the merged coordinates contained by one district. So all the dots in the figure here shows where we have those like heat data, and then the boundaries show the district's division of Bangladesh. And for the cases where one district doesn't contain any coordinates, we just take the most, like the closest coordinate to map with the district. Okay, I hope this makes sense. And then we do the same for PM 2.5 data to get the district level average PM 2.5 level across the merged coordinates. Now for the population distribution, we use the census from IPOMS. And then for each country, the availability of data set varies a lot. We decided to go with the year around 1990 and the most recent year available for each country. And here's a table showing for each country what years we are using. And then we only observe the geolocation for every individuals at the administrative level 1 and administrative level 2 divisions. And then we choose to go with the finest level we can have. And then we just categorize the population by gender, age range, and employment status into 24 groups. And then we, for the population exposure exercise, we only focus on the 4 countries because Pakistan census is not available for the most recent years. Okay, so here's a map showing like the variation across countries for the districts. We highlight the countries in this map, and each, like the purple lines in each country show the boundaries for the district. In some countries, they are not called districts, but we will keep it like unified and call them districts. And I want to mention that, for example, Bangladesh has 64 districts and Pakistan has like 32 in this analysis. But then for the other 3 countries, Indonesia, Thailand, and Vietnam, they have like about like 500 districts. So the geographical size and also population size of the districts vary a lot, but that's the best we can do from the census data. Okay, so let me show some results from the correlation between the PM 2.5 data and the UTCI and heat stress data. For every figure here, the like vertical axis shows the PM 2.5 level. That may be too small, so let me explain. And then for the horizontal axis, it is heat. It's like the temperature. So, for example, in Bangladesh, if we look at this figure, the line, the fit line here shows a negative correlation between the 2 factors. And then we actually each dot presents the district month measure, and then we separate the dots between we separate the dots by cold month and the hot month. So the blue dots are the cold month, and then the red dots are the hot months, like from April to October. So that's how we categorize those dots. And then, for example, for the takeaway from this slide is that for Bangladesh, there's clearly like negative correlation between the 2 factors. And for Pakistan, things are much worse. There's positive correlation, which means when people are exposed to high PM 2.5 level, they are also exposed to like higher heat stress. And then for Thailand and Vietnam and Indonesia, the correlation is not clear. And actually, if we change the measure for temperature from like maximum daily temperature to like minimum daily temperature, the patterns are not clear anymore. But one unique thing for Vietnam is that you can see there are some dots central, like in the middle, and it actually means the high PM2.5 level are centralized within the temperature from 27 to 35 degree. So we don't understand why, but that's just something shown by the data. Okay. Now let me move on to the population exposure measure. We actually use two measures. The first measure is called SIDS. So it calculates the share of population in one population group exposed to the heat stress by various intensity and duration thresholds. So due to the limited time, I will skip the math, but let me just show you what it means and how do we compare things. Okay, for example, if you still remember, we separate the population into 24 groups, right? And here we're showing like results from two groups. On the left-hand side, it's the female working age unemployed group, and then on the right-hand side, it's a female elderly housework group. And then the vertical axis is the share of annual hours, and then the horizontal axis is the temperature. So this is a heat map, and each number means for this population group, what is the share of people exposed to the certain threshold, considering the duration and the temperature intensity. And then, for example, the number circled there means that more than 76% of working age unemployed females experience strong and very strong heat stress for more than 20% of total hours. And the strong and very strong heat stress is defined by temperature being above 32 degrees. Okay, and then the 20% of total hours in 1 year actually is equivalent to over 10 weeks. So with those heat maps, we just compare the population groups and get the conclusion of which population groups are more exposed at the country level. So the like centralized government can put more effort into mitigating the exposure to that population group. Okay, so we have another measure. It's called STAT. It calculates the share of time the average individual in a population category exposed to heat stress. And then now, also let me just jump to the results. So still we have 24 population groups, and then each row here represents one population group. And then I just show this one column above 36 degrees here. And the meaning of all those numbers means that for each row, for each population group, the share of time on average for those people exposed to the heat above 36 degrees in 1 year is like how much. And so with all those columns, we can compare the measure across the population groups at the same threshold. And then, for example, the red color here means the higher number, the larger number. Then by comparing across the rows again, we can get a conclusion that for the 36 threshold, male employed population are heavily exposed. So that's another analysis we have. And then we realize the results from the two measures are actually similar. So we argue the results are kind of robust. Okay. So now some highlights for this project. We find that for Bangladesh, in terms of heat, in both 1991 and 2011, the elderly were more exposed than the children and the working age population. In terms of air pollution in 2011, both children and the elderly were more exposed than the working age population. Now for Indonesia, in terms of heat, in 1990, the unemployed were more exposed, while in 2010, the employed actually experienced greater exposure. And then for air pollution, in 2010, the employed and unemployed population are kind of equally exposed. And then for Thailand, things are the opposite. In 1990, the employed were more exposed, and females experienced higher exposure than males. And then in 2000s, the unemployed were still things changed a little bit. The unemployed are more exposed. And for air pollution, the elderly males were most exposed. Now for Vietnam, among the employed, females were more exposed than males, and also for air pollution, the females were more exposed than males. As a conclusion, so we find very diverse patterns across countries, and there is an urgent need for targeted policies to mitigate the effects. And then for the future research, we plan to decompose the stack measures to investigate if the increasing exposure comes from the changing demography or just the changing climate. And then we want to explore more strategies to mitigate those effects. Thank you very much.